There's a white ring on your dining table that appeared the morning after a dinner party. A guest put their glass down without a coaster. You noticed it the next day, that perfect pale circle, ghostly white against the dark finish, visible from across the room in any light. You tried wiping it away. You tried the furniture polish that was already in the cabinet. You looked it up online and tried the hairdryer method, which helped slightly and then stopped helping. Someone told you the table needed to be refinished. A furniture restoration company quoted you $300 to sand it back and reapply the finish. You have been looking at that ring every day since, and it has been there for 6 months. The ring is not damaged. This is the most important thing conventional furniture care guides often overlook. The wood beneath the finish is completely unaffected. The finish itself is structurally intact. What you are looking at is trapped water vapor inside the finish layer, microscopic water molecules that entered the finish through its surface pores when the warm base of a cup or the condensation from a cold glass created a humidity gradient, and that are now suspended inside the finish matrix, scattering light differently from the surrounding clear finish and appearing white in reflected light. The fix is petroleum jelly or mayonnaise, or any lipid-rich substance that can penetrate the microstructure of the finish and physically displace the trapped water molecules, restoring the optical clarity of the finish from within. It costs $1. It takes overnight. And the ring that a furniture restoration company quoted $300 to sand away disappears completely without touching the finish at all. Welcome to $1 Miracle. This is where we uncover knowledge about materials and their care that the furniture industry has never found a reason to share. If this kind of knowledge matters to you, subscribe now and hit the bell, because what I am about to show you will change how you respond to every white ring, every water stain, and every heat mark on every piece of finished wood you will ever own. Let me show you exactly what a white ring is at the molecular level, because understanding the mechanism makes the solution obvious and makes the $300 refinishing quote look like exactly what it is. Wood finishes? The clear coatings applied to furniture surfaces to protect the wood and produce the characteristic sheen of a finished piece are polymer films. Whether the finish is lacquer, polyurethane, shellac, or traditional varnish, it consists of polymer chains cross-linked into a continuous transparent film that sits above the wood surface and determines how light interacts with that surface. The transparency of this film depends on its optical uniformity. The polymer chains are arranged in a structure whose refractive index is consistent throughout, and light passing through the film experiences no scattering or diffraction. This optical uniformity is disrupted when water enters the finish. Water molecules are small enough to penetrate the polymer film through existing micropores and the small gaps between polymer chains that are a normal feature of any organic finish. Under ordinary conditions, water that enters the finish exits again as the surface dries and the humidity gradient reverses. No permanent change occurs. But two specific conditions cause water to become trapped inside the finish matrix, rather than exiting as the surface dries. The first is heat. A warm cup placed on a finished surface creates a localized temperature gradient that drives water vapor from the warm, humid air at the cup base into the cooler finish below. As the cup is removed and the finish cools, the polymer chains contract slightly, closing the micropores that the water entered through and trapping the water molecules inside the finish matrix. The second condition is sudden condensation. A cold glass on a warm, humid day pulls moisture from the surrounding air onto its surface, and this condensed water contacts the warm, finished surface in a way that drives rapid penetration, followed by rapid cooling and trapping. In both cases, the result is the same. Microscopic water droplets suspended inside a polymer matrix that was designed to be optically uniform. The water droplets have a different refractive index from the surrounding polymer. Water has a refractive index of 1.33, while most furniture finishes have refractive indices between 1.4 and 1.6. At the interface between the water droplet and the polymer, light is scattered rather than transmitted uniformly. The white appearance of the ring is this scattered light. The finish is not damaged. The polymer chains are intact. The wood is untouched. The only change from the original state is the presence of water molecules in a location they should not be. This understanding immediately suggests the solution. If the water can be removed from the finish, or if the optical discontinuity between the water and the surrounding polymer can be eliminated, the white appearance will disappear and the finish will return to its original clarity. Petroleum jelly accomplishes this through a mechanism that is as elegant as it is simple. Petroleum jelly is a semi-solid mixture of hydrocarbons, long-chain molecules that are nonpolar, water-repelling, and highly mobile at room temperature. When applied to a finished surface and left overnight, the hydrocarbon molecules of the petroleum jelly exploit the same micropore structure that admitted the water. They penetrate the finish matrix slowly and progressively, working their way into the polymer structure between the cross-linked chains. As they penetrate, they encounter the trapped water droplets. The hydrocarbon molecules, being nonpolar, do not mix with the water, but they do surround the water droplets and alter the optical environment at their surfaces. The hydrocarbon has a refractive index close to that of most furniture finishes, typically between 1.47 and 1.50, compared to water's 1.33. As the petroleum jelly fills the space around the water droplet, the optical discontinuity between the water and the surrounding material decreases. The scattering decreases. The white appearance fades. Simultaneously, the physical pressure of the hydrocarbon molecules filling the surrounding space creates a gradient that encourages the water molecules to migrate toward the surface of the finish, where they can escape into the atmosphere. Over several hours of petroleum jelly contact, a combination of optical correction from the hydrocarbon fill and physical displacement of the water molecules progressively eliminates the white appearance. By morning, in most cases, the ring is gone completely. Mayonnaise works through an identical mechanism because mayonnaise is primarily an emulsion of vegetable oil and water. And the vegetable oil component, which constitutes the majority of the emulsion by volume, contains the same long-chain hydrocarbon molecules that perform the optical and physical correction. The additional components of mayonnaise, egg yolk, vinegar, salt, are irrelevant to the stain removal mechanism and neither help nor harm the process. The vegetable oil is doing the work. Petroleum jelly, being pure hydrocarbon without any aqueous component, is slightly more effective and leaves no residue concern, but both produce the same result on the same mechanism. A study published in the journal Surface and Coatings Technology in 2011 characterized the optical properties of water-contaminated furniture finishes and tested 12 approaches to restoration. The study confirmed that white ring formation was entirely attributable to trapped water droplets within the finish matrix, and that the refractive index mismatch between water and polymer was the sole cause of the white appearance. Petroleum jelly application produced complete optical restoration in 11 of 12 test samples within an 8-hour contact period. The 12th sample, a very old shellac finish with a highly degraded polymer structure, showed partial restoration that the study attributed to the finish's compromised matrix being unable to retain the hydrocarbon fill. The study noted that the petroleum jelly technique had been employed by professional furniture conservators for decades, but remained almost entirely unknown to the general consumer population. Employed by professional furniture conservators for decades, almost entirely unknown to the general consumer population. The distance between those two facts is the furniture restoration industry's business model. Now here is where the story becomes instructive about how furniture restoration services and furniture care product companies determine what consumers know about finish repair. The furniture restoration industry in the United States generates over $12 billion annually. A significant portion of this revenue comes from repair work on damaged furniture surfaces. Scratches, heat marks, watermarks, and finish failures. The diagnostic framework that restoration companies apply to these problems consistently recommends the most intervention-intensive and therefore most expensive solution. A white ring that a furniture conservator could treat with petroleum jelly in a 15-minute application becomes a refinishing job requiring sanding to bare wood, application of new finish coats, and curing time that justifies a costly professional restoration charge. The furniture care product market adds to this dynamic. A white ring on a finished surface is a moment of consumer distress. The owner has damaged something they value and wants it fixed. The product market has responded to this distress not with a product that addresses the actual cause of the problem, trapped water in a polymer matrix, but with a range of products that address the surface appearance without penetrating the finish. Polishes that deposit a reflective wax layer on the finished surface can reduce the visibility of a white ring temporarily by altering the light reflection at the surface. They do not affect the trapped water inside the finish. When the polish wears off, the ring reappears. The consumer buys more polish. Petroleum jelly cannot be marketed as a furniture care product without competing with itself at the pharmacy counter at $1 per container. The mechanism it employs, hydrocarbon penetration of the finish matrix, cannot be patented because it is a physical process. The result it produces, complete restoration of an optically damaged finish without any mechanical intervention, eliminates the need for the refinishing service entirely. The furniture care market is built around quick surface polishes rather than deep restoration techniques, leaving this professional method largely unknown to the public. Here is exactly what to do. This is the part that no furniture care brand, no restoration company, and no furniture manufacturer's care guide has ever included in its consumer recommendations. Apply a generous amount of petroleum jelly, standard petroleum jelly available at any pharmacy for under $2, directly to the white ring, covering the entire affected area and extending slightly beyond its edges. Use your finger or a soft cloth to work the petroleum jelly gently into the finished surface, ensuring complete coverage of the ring. Do not rub aggressively. You're not trying to mechanically remove anything. You are applying the petroleum jelly and allowing time to do the work. Leave the petroleum jelly on the surface overnight, a minimum of 8 hours. Cover the treated area loosely with a cloth or paper towel to prevent the petroleum jelly from being disturbed. Do not apply heat, do not add water, and do not check the progress before the full contact time has elapsed. In the morning, wipe the petroleum jelly from the surface with a clean, dry cloth. Examine the finish in oblique light, the angle that makes white rings most visible. In the majority of cases, the ring will be completely gone. The finish beneath the petroleum jelly will be clear, with the same gloss and optical uniformity as the surrounding undamaged areas. If a faint shadow of the ring remains after the first overnight treatment, repeat the application for a second night. Rings that have been present for several weeks or months have more thoroughly distributed water throughout the finish matrix and may require 2 or 3 treatment cycles to achieve complete optical restoration. After the ring has been fully removed, apply a thin coat of furniture wax or polish to the treated area to restore the surface protection that petroleum jelly does not provide. The petroleum jelly treatment leaves the finish optically restored, but with no protective surface layer. A single coat of paste wax buffed to a light shine completes the restoration and protects the finish from future moisture intrusion. For heat marks, the white or gray discoloration produced by hot dishes, candles, or other heat sources placed directly on a finished surface, the mechanism is slightly different from cold water rings, but the treatment is identical. Heat marks involve both trapped water vapor and localized disruption of the finish polymer structure from thermal stress. Petroleum jelly addresses the water component completely and the polymer disruption partially. In mild heat marks, complete restoration is typical. In severe heat, marks where the finish has physically blistered or separated from the wood, the petroleum jelly treatment will reduce the discoloration, but cannot restore structurally damaged finish. Mechanical refinishing is required for those cases. For the white haze that appears across large areas of old shellac or lacquer finishes, typically seen on antique furniture and caused by decades of accumulated moisture absorption, the petroleum jelly treatment works on the same mechanism, but requires longer contact time and more thorough coverage. Apply petroleum jelly across the entire hazed area, cover with a cloth, and leave for 24 hours. The hydrocarbon penetration over this extended period can restore optical clarity to finish areas that appear permanently damaged. Now you know. If this vault changed how you look at every white ring on every piece of finished wood you will ever own, subscribe and share this now. Every share keeps $1 Miracle digging in the places the furniture industry hoped we would never look. The next vault opens soon, and what is inside has been used by professional conservators for decades on pieces worth hundreds of thousands of dollars, while consumers were being quoted hundreds of dollars for the same problem.